Hey, seventh grade. So our learning target today is I can combine like terms. You should be on page 6 in your packets. So we're going to start by talking some definitions. Terms. What are terms? So if you think about what terms are, they really are parts of an expression. They are separated by add and subtract. So we'll talk about what that means in just a second here. Go ahead and copy those notes. So parts of an expression separated by add and subtract. So we would say in this first example that 3x and 4 are the terms. We have two terms in this expression. Term number 1 is 3x. Term number 2 is 4. They're separated by an add sign. So those are called terms. When we have something called like terms, it means that they have the same variable parts. We'll take a look at what that looks like. But like terms have the same variable parts. So the same letters to the same power. Same letter, same power. Same letter, same power. Maybe we'll even write that. Let's go ahead and write that in that box. So same letter, which means variable, same power. Same letter, same power. Okay, so some examples of like terms then. So things that are like versus things that are unlike. So let's go ahead and organize this table of some ideas so that you can see the difference between like terms and unlike terms. So we'll start with something very simple. 2y and negative 8y. We would say that those are like terms. Same variable, same power. It doesn't matter what the number in front is. We'll talk about that in a second. It's called a coefficient. But it doesn't matter what that is. It's about the variable and the power. So if I highlight the variable is y. The power is 1. Y to the first power, y to the first power. Those are like terms. So let's look at something that is unlike. Unlike terms would be that same 2y, but if I were to change the power and say negative 8y squared. Now when I look at the variable, yep, same variable. Problem though is this power is different, so those are unlike terms. All right, let's take a look at another example. If we have, let's say, 3rs and just rs, which is the same as saying 1rs. Those are like terms. Same variables, r and s, same power. Something that's unlike then is if we had 3rs and then I had just, let's say, r. Those would be unlike terms because we don't have the exact same variables to the exact same power, unlike terms. All right, let's do one more example of like terms. Let's say 1/4 m squared and 7m squared. Everybody should be writing 1/4 m squared and 7m squared. Those would be like terms. Why? Because they have the same variable m to the same power, m squared, m squared. Again, we don't care about the number in front. We'll talk about that in just a second. What would be something that's an unlike term? Well, having that 1/4 m squared, and then maybe having like 7, let's change the variable there, p squared. Those are unlike terms because the variables are different. M squared and p squared, different variable. Even though the power is the same, you need same variable, same power, like terms. So hopefully you kind of have an idea of what like terms are. So let's talk about that number that's been in front. So we have this 1/4 in front, this 7. What about that number? We haven't even looked at that number. That's called the coefficient. So the coefficient, I'm going to throw my definition down here because of space, is the number part of the term. The number part of the term is called the coefficient. So you can see an example here that 5 is the coefficient of 5x, the number part of the term. We're going to deal with that as we do some examples down here called combined like terms. So far in this lesson, what we talked about are what are like terms. Like terms have the same variables, the same power. Unlike terms do not. So if we have like terms, we can combine them through an operation of add or subtract. So here I have 3m's plus 5m's, and I'm checking to see same variable, yep, same power, yep, we can combine. So to combine then, we're going to put all the m's together. So I'm going to go ahead and put a blank and then m's. Same variable, yes, same power, yes. Now we combine those. 3 plus 5 gives us 8m. So our answer is 8m there. combine like terms. That's as far as we can go because we're just simplifying the expression. We do not know the value of m, so there's nothing else we can do with that. All right, so in the next example, trying to combine like terms, we have to have the same variable to the same power to combine. So the same variable, yes, same power, yes. So the variable and the power that we have here is r to the first power. So we have this r to the first power, r to the first power. So the name of this is going to be just r to the first power, and now we combine. Negative 6 plus 2. Negative 6 plus 2 becomes negative 4. Negative 4 power and variable r to the first power. Negative 4r is our answer to that expression. All right, guys, next problem here. We're going to say, I said no. We're going to stop, chop, chop right here. And now we're going to take a look at the variable and the power. Looks like we have the variable w, first power, w, first power, w, first power. Same variable, same power. We got it. The name of that is going to be w then, w to the first power. And now we just combine the numbers, the coefficients we put together. So we would have 12 plus 15, which gives me 27. And then I'm going to add a negative 8 or take 8 away. If I take 8 away from that, that would leave me with 19 w's. Now, if I'm going too fast, go ahead and pause the video. Answer should be 19w there. Otherwise, we're going to move on. All right, so let's take a look at this next example, 7th grade. Here we go. We have variable t to the second power. Do we have any other variable t's to the second problem in this problem? Looking for the variable t to the power of 2. No. I have a variable t to the power of 1, but those are unlike terms. And then I have just this number, which is called a constant in math. So I have t squared, I have a t, and I have a 4. What can I put together? Well, I can only put things together that are like terms, which means it's the same variable, same power. Well, there isn't anything there for me to do. I only have that t squared, I have a t, and I have the number 4. So we would say in this problem that there isn't anything for us to do, and the answer we do say to this is called already simplified. Everybody should be writing already simplified. Already simplified. That is our answer. Kind of a weird answer in math, but that is our answer to say, hey, there isn't anything we can do more to solve that problem. All right, next problem here. We're going to say, no, I stop, chop, chop here. I stop, chop, chop again. A stop, chop, chop again. So I stop, chop, chop 3 times in that problem. Should be stop, chop, chopping 3 times in that problem. Go ahead and catch up there if you got behind. Okay, so what I'm looking for is the same variable, same power. So we're going to take some baby steps here, and I'll try to slow down a little bit if I'm going too fast for you here. So the variable is f to the first power, f to the first power. As I'm searching through this problem, I'm looking for f to the first power. I don't see any more f's to the first power, so I'm going to go ahead and give myself a blank and leave a spot for f to the first power. That becomes negative 3 plus negative 3, which is negative 6 f's to the first power. So we're done with those first two. Next thing I'm going to look for is the same variables to the same powers. Same variable, same power. I have e to the first power, f to the first power. Looking. Here's another one. E to the first power, f to the first power. So I'm going to grab the coefficients in front. So the name of that would then be EF. How many EFs do I have? Well, I have $4 in the bank, and it looks like here I'm going to take negative 6 away. So I have 4, take away negative 6, gives me negative 2 EFs. And the only thing that's left then is this negative 4 EF squared. There's our answer there. Negative 6F plus negative 2EF plus negative 4EF squared. Really in any order. We can put this in any order because of the commutative property, but that is the answer to that problem. We cannot combine any further there because it has to be the exact same variable to the exact same power in order to combine like terms. So we are done. Go ahead and catch up if that was too fast. We have one left before that summary. All right, here we go. Austin, no, we're going to stop, chop, chop right here in the end. Combine like terms, we're going to look for those variables. Variable is w, power is squared. Variable w, power is squared. So we have w squared. I pay $14. I have 18 in the bank. So negative 14 plus 18 gives me 4w squareds. Positive 4w squared. Go ahead and look at that. We're combining those because it's the same variable w to the same power of 2. And then when I combine negative 14 plus 18, I have positive 4. Then we have this rule that's called, if I haven't used it, I drag it down. Is there any way for me to put these together? Well, I need the same variable w to the same power to combine like terms. So if I highlight my powers and variables there, I have a w squared and I have a w to the first power. We are done. So the answer to that problem is 4w squared plus negative 8w, done. Okay, guys, so our lesson today was called Combine Like Terms. In order to combine like terms, you need same variable, same power. So let's go ahead and take a look at our summaries. For our summaries, first you need to stop, chop, chop everything. Make sure that your signs are correct. Stop, chop, chop everything. After we've done that, then, you're going to only combine variables that are exactly alike. Same variable, same power. We talked about that. Exactly alike. Okay, and once that is done, then we would say that the x, if there's a lonely x, any of the problems that have a lonely x, it has a variable, or it has a coefficient, sorry, of 1. So an example would be if you had 2x minus x, this is really like a 1x there. Just like a 1x there. So we always put a 1 in front of a lonely x. Okay, guys, so combining like terms was our lesson for today. Your job is to finish page 7 for homework tonight on combine like terms. If you want to use a highlighter to help organize same variable, same power, that's helpful if you get stuck. Otherwise, your homework is page 7. Have a fabulous night, 7th grade.